Performance differences between males and females are substantially greater when humans jump for maximal height versus distance. We postulated that well-known sex differences in body composition, specifically for relative lower body muscle mass fractions for athletes, would cause the sex differences in performance to increase as jump takeoff angle became more vertical, and thus the force required to elevate the body's mass against gravity became greater. We tested this idea using triple jump, long jump, and high jump data from World Athletics Best Performers lists and counter movement jump data collected from collegiate athletes performing jumps on our force plates in the lab. What we found was that across the 4 jumps analyzed, the more vertically oriented the takeoff angle, the greater the sex difference observed. This ranged from the most horizontal jump, triple jump, at 17.4%, to the straight vertical jump of the counter movement jump. However, the most revealing data came from the force data collected for the counter movement jumps in the lab. The between-sex differences in jump height of our samples, 42.1%, was 8 times larger than the differences in total ground phase vertical force application at 5.1%. In order to move vertically, athletes must exceed their own body weight in force applied. When we analyzed the net force above body weight, the sex difference observed was greater at 24.1%. From this analysis, we conclude that small differences in mass-specific force application result in much larger differences in performance for more vertically oriented and gravity-opposed jumps compared to horizontal. The more general implication of these findings goes beyond just sex differences observed that we used as a tool. These implications include training and performance. For any training-induced improvement on mass-specific force capability, the improvement in performance for vertically oriented actions will be greater than for horizontal.